All right, guys, complete to do now. It's I believe it's slide 7 on your slides. So let me just show you, and this would be in your notes. So it would be this slide here. Where is it? This should be your slide 7. Okay, this is what you're completing.
No, you just go ahead.
All right, so what is the contour interval of this map? Erica? She says 20. Okay, so what you did is you had to find 2 index contours. We have one here, 700. We have one here at 800. What you do next is you subtract those 2 numbers. That gives me 100, right? Then I divide by 5. 100 divided by 5 is 20. So what you do to check yourself is you plug in the values to see if it works. And you had to do that anyway because the second part of the do now was what is the value of each contour line. So this one here should have been 680. You got 7 here, 720, 740, 760, 780, 800, and then 820. All right? Good? Anthony, you good? All right. So what I want to do first, before I go over contour map 3, which you were supposed to do for homework last night, and you guys did turn it in when you were done, right? Okay. So I'll go over that, but first I want to show you a quick video clip. Now, I would pay attention, especially if you're struggling with this, because, again, this is going to go over how to read a topographic map.
Topographic maps are a little different from your average map. Not only do they show the location of things like roads and trails, but once you get the hang of reading them, they also help you visualize 3-dimensional terrain from a flat piece of paper. Topo maps use 3 main mechanisms to describe the terrain. In this video, we're going to cover how to read the map's contour lines, how to understand scale, and how to read the symbols and colors found in the map's legend. Contour lines are what really make topographic maps something special. These lines connect all the points on the map that share the same elevation. By looking at how the contour lines spread out and come together, you can get a good sense of what the terrain looks like. When the lines are packed close together, that tells you that the elevation is changing a lot in a short distance, so the terrain is quite steep. As the lines spread out, the elevation changes more slowly, so the slope is more mellow. Contour lines can also help you visualize the shape of the terrain. For example, as the lines form smaller and smaller circles, they're probably showing a peak. Spend some time with a map of a familiar area and see if you can pick out terrain features just by looking at the contour lines. Every 5th contour line on a topo map is thicker than the others, and those thick lines are called index lines. At some point along every index line, you'll find the elevation for that line written on the map. The change in elevation from one contour line to the next is always the same on the map. And most maps have either a 40 or 80-foot contour interval. If your map has an 80-foot interval, that means that each contour line is 80 vertical feet away from the next. You can find all the specific details about the contour intervals and index lines for your map in its legend. Scale refers to the relative distance of the map. For instance, this map scale is 1 to 12,000. That means that 1 inch on the map represents 12,000 inches in reality. Another map of the same region is 1 to 50,000 and covers a larger area, but in less detail. The important thing is that the map with a smaller scale will show a smaller area, but with more detail. Understanding the level of detail on your map is handy when planning your route, but it isn't much help if you want to calculate distances efficiently. That's why maps also have a small representative scale near their legend. This scale shows you the relative distance of a mile or a kilometer on your map, and you can use the edge of a compass or even a piece of string to help figure out just how far away that peak is. One of the first things to look for on any new map is the legend. The legend is like the user's guide for your map. It's where the various lines, colors, and symbols are defined. When it comes to the colors on the map, the idea is that the darker the color, the denser the vegetation. As you get closer to the top of a peak, you'll notice that the colors get lighter as the forest thins out. And of course, streams and lakes are represented in blue. Alongside the list of symbols, there are a few other important pieces of information, like details about the contour lines and the date of the map's most recent revision. This is also where you'll find the magnetic declination for the region, which you'll use to set up your compass. When you combine your understanding of contour lines, scale, and your map's symbols and colors, you can almost visualize your whole trip before you go. The next step in becoming a backcountry navigator is to learn how to use your compass alongside your map. So click here to check out that.
All right, so you're actually going to do that to basically today to look at the contour lines and then be able to visualize it three-dimensional. You'll have to match up the three-dimensional image with the appropriate lines. But first, I want to go over last night's homework. So open that up, please. That would be contour map 3, which is this one right here. All right. So, again, just like the previous two maps, you have to find the contour interval of this map. In order to find the contour interval, you have to go ahead first and find 2 index contours, 2 contour lines that are labeled with their elevation. Remember, index contours are also thicker than the other lines. So, what are my 2 index contours I can use on this map? 2 lines labeled with its elevation. Erica? 50 and 100. Good. So what's 100 minus 50? 50. Divide that by 5. 10. So let's plug in the values to see if that works. 50, 60, 70, 80, 90, 100. So yes, my contour interval for this map is 10 feet. Good. The next question. All right, so it's asking you, what is the elevation of all the contour lines that outline the coast? What is the elevation of that line that outlines the coast? Remember, the coast surrounded by water. So what would the elevation be? 0. It's at sea level. It would be 0. Good. All right, so this is asking you, what is the shortest distance between Key Island and Sound Beach? Here is Key Island, here is Sound Beach. So again, if you want to find the distance between 2 points, in the video they said you can use a piece of string, you can use a piece of paper, pencil, your finger if you want. So what I do here is I'm going to take a piece of paper, I'm going to put it at the edge of Key Island, and then the edge of Sound Beach, which would bring me to this point on the piece of paper, right? So I'm going to match that up with my scale here. Well, if you notice, if I start at 0, because I'm dealing with a small area, I want to use the quarter miles over here. So when I look at it here, if you notice where my finger is on the 0, the edge of the paper stops on this line. Therefore, the distance between those 2 points is a quarter of a mile. All right? So again, when you see a scale like this, it's going to have a whole mile on this side, or whatever miles the map is using, and it's always going to have the shorter ones on the side here. Okay? All right. So next question. The greatest elevation at Barrier Beach is less than what? Well, Barrier Beach is here, right? Little island. And we know that this outer contour line here, because it is surrounded by water, is 0. What if I drew another contour line here? What would the value of that be? Well, we know that the contour interval of this map is 10, right? So if I drew another line in there, what would the value of that line be? Say it again. 10, right? Because we said this is 0, so if I drew another line, it's 10. So we can't draw another line, so the greatest elevation is less than 10, all right? Less than 10. You understand that? Because if it was 10, I would have to have another line. I don't, so I know it's less than 10. All right, next question. High River is probably flows most rapidly at or near which foot contour line? There's High River. So kind of going back to what you learned last year in science, right? So going back to physical science. So I draw a hill here, and I put points A, B, C, right? If I roll a ball down that hill, at what letter is the ball going to be at its greatest velocity? A, B, or C? Not B. It's going to be at its greatest velocity towards the bottom. All right? So if you look at High River here, right? High River is going to be at its greatest velocity right about here, right? Towards the bottom of that. So that would be at the 0, 10, 20 foot contour line is where you expect High River to be at its fastest. All right. Where is a depression located? Where is a depression located? Remember, a depression is a contour line that has dashes through it. High sink, right here. There's my depression. So remember, the depression, I'm not going up in elevation, I am going down in elevation. All right, next question. In which direction must you move to travel from Park Beach to Key Beach along Ocean Highway? All right, so there's Park Beach, there's Key Beach. Which direction must I go in order to go from Park Beach to Key Beach? Which direction? Which direction is this? What?
Right.
Did you say right? No, direction, cardinal direction wise. Northeast, southwest, what? Then, no. Remember, here are your cardinal directions, right? You have north, northeast, east, southeast, south, southwest, west, northwest. So if I'm going in this direction, I'm going to the northeast.
Because on the left of the map, those arrows that's showing you where north is. It shows magnetic north, true north. So that's telling you north is up.
To the nearest foot, what is the highest possible elevation of High Hill? So here we go. Let me just erase some of this, make it less of a mess. So here is High Hill, right? The highest possible elevation is what we're looking for. So I know that this contour line is 100 because it's labeled. What would that next line be? 110. What would that next line be? What did you say? 120. What if I drew another line in there? What would that be? 130, right? How high can I go without hitting 130? 129. That's my highest possible elevation at High Hill, is 129. All right. I think that was complicated. Wait till you see this assignment. All right. So, on Google Classroom, I posted something. Let me just bring it up here. All right. So this is what I posted. So basically, you have two slides here that you have to do. You have to drag the image to match the contour map to the picture of the landform that it represents. So here, why can't I move them? For me, it's not working. Oh, that's why. I hope anyway. Let's see if that did it. It's not letting me move it. Oh, that's because I didn't make a copy. Hold on a minute. All right, so now this should do it. Yes. All right. So again, you're looking at these contour maps here, and you have to match it up with the correct side view. So basically, that's what I was telling you before. You're taking a 2D image and you're trying to visualize it three-dimensional as it is on the right side here. So let me give you a hint. I would have the highest elevation on this map would be over here, right? Lower elevation over here. More steep of a slope over here because the lines are closer together, whereas I have a more gradual slope on this part of the island because they're spaced further apart. All right? So I just actually described one of the 3D images for you. So this image here, remember I was just pointing this out that I could tell a lot from this map. I could tell that this is has a larger elevation, higher elevation, because there's more lines in that area, closer together, which means I'm looking at a steeper slope. Here, elevation is not as high, and because the lines are spaced further apart, I know it's a more gradual slope. What image does that match up with? This one right here, right? So let's move this. It's not going to let me do it on the screen. So we'll move this, and we'll put this one up here, all right? That's what it would look like from the side view. What about this one here? This one here, I can tell I have two peaks, right? Because I have two inner circles here. Basically, the elevation is basically the same. The overall steepness is the same on both sides. What picture would that match up with? The last one. So move this, put this here, and obviously this one is here. All right, because the peak is in the middle as it is here. Good. All right, let's go on to the next one. Next one, I have two hilltops, here. This hilltop's going to be taller. It's going to have more of a steep slope. This hilltop here won't be as tall, and it's going to be a more gradual slope. So what picture does that match up with? The second one. Excellent. Good. Now, this one should be really easy because I have two peaks. The spacing of the lines is the same on both sides. Both have the same elevation. What picture does that represent? Anthony? The third one. And this one, that last one was easy because if you look at the picture, basically it looks the same on both sides. Okay. Should I start them on the gizmo? I mean, it's kind of a... Right?